Okay, so I suppose we can start the live session of the course on manufacturing processes, casting and joining. So I have few questions which some of the candidates have posted. So I will start probably with those questions. Let me first see, yeah. Okay, the first question is asked by Mr. Anmol Choudhury. What is the material quality that will change after casting? I think you are talking about the brittleness of material and the ductility of material, if I am not wrong. Okay, so after the casting, the brittleness or the ductility of the material do not change. Okay, it only changes with the heat treatment. It's like if the metal is heated up and then put it in the water or in the oil, that is kind of quenching. So here the hardness will be more. That means the brittleness of the material will increase and the ductility will be less. To increase the ductility, if you heat it up and then put it in the air, so it will be cooled down gradually and the ductility will be more. Okay, but not for the casting, but it can happen only when you are heat treating the material. I hope it is clear. Okay. All right. So the second question that has been asked by Mr. Anil P. You are saying that, hello, Professor, please discuss these questions. In Shrovinov's rule, how do mold constants vary with different mold materials? Okay. Now, if you go through the slide number 56 in the casting, you will see that it is discussed in great details that the mold constant depends on the mold material, on the thermal properties of the casting metal, and the pouring temperature. Basically, these are the pouring temperature relative to the melting point of the material. So these are the three basic properties on which the mold constant will vary. Now, how they will vary, it depends on what kind of material you are using. So these are all given in the handbook, and from the handbook for different kind of materials, you can find out the value of the mold constant. Okay, so basically these are the three parameters. In Slovenia, okay, why is investment casting preferred for complex shapes despite its higher cost? Well, if you see the investment casting process, you will see that the pattern making is not like the sand casting. Meaning that in case of sand casting, if the casting is very complicated, in that case the pattern will be very complicated, and the pattern sometimes is difficult or not possible to make. Okay, and moreover, in the sand casting, for example, you are putting the pattern in two halves. Okay, and very complicated intricacies cannot be done by sand casting. It can be done by the investment casting only. For example, the ornaments, very fine ornaments, so where you have the very intricate details, that can be done only through the investment casting because the pattern making is easier. That is the basic reason. Okay. And despite the higher cost, yes, because it is not possible to make with any other casting process except the investment casting. Okay, because it is made of wax and it's very easy to make. Okay. What are the main differences between hot chamber and cold chamber die casting, and how can we minimize common casting defects like porosity or misrun? These are two different questions. Okay. Now, like hot chamber and cold chamber. Hot chamber and cold chamber, basic difference is that when the mold, in both cases, molten metal will be poured. Okay. When the molten metal is poured, molten metal will go through a passage which will be heated up in the case of hot chamber and will not be heated up in case of the cold chamber. There's the only difference between them. Otherwise, all the other things are the same. Now, why it is done? Now, to increase the fluidity of the molten material. Okay, if the metal property is such that it has the very high melting point, or it has a very rapid cooling process, in that case it has to be heated up. In that case, the hot chamber is required. Otherwise, cold chamber die casting is used. How to minimize the common defects like porosity or misrun? Now, you have to see why porosity is occurred and why misrun is occurred. Porosity is something when the gas is going through the casting or the small bubbles are passing through the casting, it makes the porosity. It creates the porosity, okay? And misrun is when the molten metal is poured, but it will not reach all the corners of the mold. Before reaching all corners of the mold, it will solidify. Okay. Now, what are the reasons? So therefore, to minimize the casting defect like porosity, you have to have the enough venting, okay, so that the gas can be taken out properly. Okay. And the reason for gas formation should be minimized. What are the reasons? For example, there can be some material which can burn when the molten metal is poured in the casting mold. And if the mold has those kind of materials included or inclusions, so that the gas is formed, that has to be avoided. So in that case, the gas generation will be less and the porosity will be less. Misrun. Misrun is, as I said, that molten metal before reaching the intricate places or the corners, it can actually solidify. That means if you are having the temperature low, okay, pouring temperature less than required, or if you are pouring the molten material slowly, okay, in those cases, the metal will not molten metal will solidify before reaching the intricate places. So that which is called the misrun. Okay. Now the next question is asked by Lina. How is optimum riser design determined in practice? Okay. This also we have discussed in very details. If you go through the slide number 43, you will see that it is in details discussed. And particularly it is said that basic requirement is that when the height of the riser and the diameter of the riser is the same. Okay. Therefore, if you see the volume, which should be the optimum volume, which is given by pi d cube by 4. Okay, so it has to be pi d cube by 4 when h is equal to d, and that is the final derivation which is given in the slide number 43. Okay, so please go through that. And as I replied to this question, that h has to be equal to d, and the optimum volume of the riser has to be determined by the pi d cube by 4. Okay. Next question is asked by Arindam. How does heat density affect the quality of fusion weld? What are the microstructural changes that occur in the heat affected zone? Okay. Now you go through the slide number 16 in the joining processes. Okay. Heat density affect the quality. If the heat density is more, in that case, it will burn, and the heat density is less, the welding will not take place. Okay. Heat density is less, welding will not take place because the heat will be distributed to the base metal and it will not go to the spot where it has to be welded. Okay. And if the heat density is more, so it will be heat affected zone will be more, and overall the welding will be of worse quality because it will burn simply. Okay. What are the microstructural changes that occur in the heat affected zone? Well, when the welding process takes place, once the welded zone is made, so then the metal is still in the liquid state, and it will start solidifying gradually. So it will solidify faster when it is in touch with the base metal. That means it is in contact with the base metal. So that portion will be solidifying very fast, and therefore very fine grains will be formed. Okay, but away from that, which is called the melt boundary. Okay, in the melt boundary, the heat is still very high, and therefore the molten metal will solidify gradually, and the grain structure will be coarse. So the grain structure will be coarse and the fine within the heat affected zone, depending on the side which you are looking at. That means if you have at the boundary with the base metal, it will be finer grains. Both are recrystallized, of course. Fine grains and coarse grains in the heat affected zone, both are recrystallized. Okay. Next question is asked by Mr. Okay, it's asked by Harshita. Question is that in TIG welding, why are non-consumable electrodes used, and what role does the inert gas play? Okay, TIG welding is a tungsten inert gas welding. Okay, so as the name says, here there is a non-consumable electrode used, which is a very high melting point. Okay, and that is the tungsten, and that is used so that if you go through the slide, well, somewhere in the TIG, I have not written down the slide number. This will actually provide this electrode, tungsten electrode will provide the stable electric arc. That's the basic concept behind using the tungsten non-consumable electrode, to get the stable arc, which is very much required to get the high melting point or the high energy. Okay. So once again, in the case of tungsten inert gas welding, non-consumable electrodes are used as a tungsten material which will not melt because of the high melting point, and it is used to to provide the stabilized arc. Okay, what role does the inert gas play? Inert gas play to shield the arc, which is very important. If the arc is not shielded, in that case, the heat density will be less, and the welding will be not performed well. Second question is, how does laser beam welding differ from the electron beam welding in terms of energy source and applications? Okay, that's a good question, because both are actually the same, in the sense that both use the high intensity beams of electromagnetic energy, and in both cases of laser beam welding and the electron beam welding, the density is about 10 to the power 3 to 10 to the power 10 to the power 10 to 10 to the power 13 watt per meter square in both cases. Okay. Now the difference between them is basically the and both the processes, by the way, they produce deep, narrow, parallel sided fusion zones with a very narrow HZ, the heat affected zone. Okay, in both cases. Now the basic difference between them is in the required environment. First thing, that means in electron beam welding, the high temperature is created by the electrons, and in case of the laser beam welding, it is the photons. Okay, in the form of the photons. And in the electron beam welding, it is in the form of the electrons. Okay. Now, the basic environment that is required for the electron beam welding is the vacuum. Otherwise, the energy of the electron beam will be less, because it will be colliding with the air molecules, and therefore it has to be performed in the vacuum. Whereas the laser beam welding is not required to be performed in the vacuum. It is not performed in the vacuum because laser beam is not affected by the air. Okay. So that is basic difference. That's the environment. Second is the penetration depth. In case of electron beam welding, the penetration is deeper because because it is not colliding. It is performed in the vacuum, as I said, and the density is higher. Third is the cost. Laser beam welding equipment is less costly. Electron beam welding is costlier. Okay. Electron beam welding is costlier simply because it has to be done in the vacuum. And each time you are performing a process on a particular material, on a particular part, you have to create the vacuum. Okay, then you have to take out, while taking out the part, you have to again create the vacuum for the next part. So therefore, it becomes really expensive. So electron beam welding is expensive, more expensive than the laser beam welding. Okay, that is one thing. Electron beam welding has to be performed in the vacuum environment. Laser beam is not. And the penetration of the electron beam welding is deeper than the laser beam welding. So these are the basic three differences between the laser beam welding process and the electron beam welding process. Okay, so I hope I have replied to all your questions which you have shown there. Okay. Okay. Any other question? I can't see in the in your responses.
Thank you so much, sir, for answering all those queries posted via Google form. So few students have joined directly on the Zoom. Let us take questions from them, sir.
Okay.
Yeah. So Dr. J. Mahashar Ali, do you have any query?
Okay, you have to unmute. First of all, you are all muted, so you have to unmute so that we could hear your question. Okay.
Mr. Home, Ms. Ammu, and then Juwal Tripura. Do you have any queries? You can unmute and ask. Otherwise, you can post it on the chat also.
Yeah, right.
No, sir, I don't have any questions right now.
Okay, so in case you have any question even later on, you can please post it. You please post it on the forum and I will immediately reply to these questions. Okay, and I hope sincerely that all the answers that I have given, you understood. Okay, and those who are listening also to those to those replies, I hope they will also understand. Okay.
Maybe we can wait for 2-3 minutes, sir. In case if there are no queries, then we will wind up, sir.
Yes.
And
no
then
problem.
before winding up, you can talk about the examination pattern. Because a lot of students have registered for the examinations. Close to 975 students have registered for the examination.
Okay,
so it will be very helpful if you could give some insights on the examinations.
Sure.
Thank
so
you,
I can do that meanwhile because
Yes,
there is no question, it seems, right now.
Right,
So
sir.
about the exam, I will tell you, first of all, the exam will be very simple. Okay. By simple, I mean to say the exam, whatever questions will be asked, will not be outside anything that I have not told you during the exam, during the the lecture hours. Everything that you have in the lecture notes, in the slides, okay, if you go through that, it will not be difficult for you to answer to those questions. So therefore, overall, I'll tell you that exam will be very simple. Now, I have even simplified it. All questions will be, A, B, C, D. Okay, you have to select one of the options. All the questions. There are some very basic numericals, and the answers are given in the 4 options, in terms of 4 options. and you have to select one of the options. You don't have to write the answer there. Answers are there. Okay, but one answer is right. So MCQ will be basically for all the questions. Okay, for very simple numerical questions, answers are given in terms of 4 options, out of which one option is right. Okay, and the material will be strictly, absolutely from the lecture materials that I have given. So if you go through that, there will be no problem in answering these questions. All right. Now, basically what I have seen that the questions that have been asked, there also, if you go through the slides, you will find all the answers, in fact. Therefore, I was mentioning that where you will find the answers in which slide of casting or the joining. All right. So what I request is that please go through all the slides, all the lectures that have been delivered, okay, and revise them. There are some reading materials. I have given those textbooks also, and there are numerous number of textbooks which you can, any one of which you can follow, okay, for more details. And if you want to do that, but otherwise material will be given in the lecture materials, okay. It seems there are few other candidates who have joined. So in case you have any questions, so kindly either you can speak out or you can write it in the chat box. Okay.
On YouTube, one participant named
Yeah.
Dr. Sagar Chokshi has
Okay.
posted,
Okay.
for numerical, we have to use calculator inbuilt into computer, is it?
Yes.
I have already answered. Yes, sir.
Yes. Yes.
So they have to use inbuilt calculator.
Yeah. In fact, what I should tell you that for the numericals, I have given the numericals in such a way that you may not use even the calculators. Okay. But if you want to use it, if you have to use it, you can use it inbuilt only. You are not supposed to get a calculator with you. Okay.
Yes, sir. Physical calculators are
Yeah.
not allowed
And
inside
you can practice that. I think it is given in the website. You can, Mr. Murali Krishnan will tell you in details.
Yes, sir. There is a link provided in the announcement section.
Yeah.
Please try that calculator and get used to it.
Yeah, right.
Thank you, sir. Participants, do you have any other queries? Please feel free to ask, sir, without much delay.
And once again, if you have any other question, even after this live session, you can still post it in the forum and I will immediately answer to these questions. Okay. Okay, so altogether there are 7 participants I can see. So I hope all the things are clear. So that's why uh, questions are not raised right now. Okay. It will wait for some more time for your questions if you have any, and then we can close.
Yes, sir. We can wait for 2-3 minutes.
Yeah, sure.
Yes, sir. Thank
About
you.
the exam, anything else that I would like to tell, Mr. Murali?
Hall tickets, it has
that
been.
You can tell. Hall tickets will be
Yes, sir.
sent to the
Yeah,
candidates.
IIT Madras team has already shared the hall tickets yesterday night. Please check your emails and then download it and print it out.
In case of any difficulty, you can write to us.
Yes, definitely. You can post your doubts on the Q&A forum. We will be ready to help you out.
Yeah, so I suppose there are no other questions because participants are
Sir,
also.
one more question Dr. Sagar has posted, sir. I will just repost it in the Zoom chat, sir. Just a second, sir.
Yeah.
Okay. Hello, Mazli, how are you?
Sir, I have posted it on the Zoom chat. Are you able to view it, sir? The question is, in
no.
investment casting, okay, I'll read it out, sir, for you. Dear sir, in investment casting, how we can burn the flax before pouring off molten metal?
Okay, so it has to be it has to be put on the fire or put it in the hot water. That's how normally it is done. Okay, because it's wax. Wax will melt out and the shell will be remaining for the investment casting. So sometimes it is burnt in the fire. Sometimes it is poured in the hot water, provided that the shell is not soluble in water in that case. Okay, but otherwise it is on the fire. In fact, I have shown a video. Okay, there probably you can see the entire process of the investment casting. As far as I remember, there is a video there, and I have shown it to the students, participants during the lectures. So please go through that video. Okay, there it is all in great details. It is shown how the steps of the investment casting.
Thank you, sir. And the second part of the question is, how we take outside thoroughly from all parts?
Oh, you have to break that shell from outside. Yes. Outside shell is broken. It is broken by a vibrator. Okay, because it's not very hard. It is the entire thing is put on the vibrator, and the shell will be broken, and the parts will be coming out, and it will be separated by the grinders. Okay, by fine grinding.
Thank you, sir, for answering the question posted by Dr. Sagar Chowksi. Dr. Sagar Chowksi, if you have any other.
Yeah, that yes. Sagar, if I hope you are satisfied. If not, then you can post the questions again. Your doubt.
ये करवाएंगे तो इनको जो भी डिटेल्स हैं वो
We'll just check the YouTube and let you know, sir.
Yeah, there is a movie. I have shown it in the video.
Yes, a video clip is there, sir, related to this thing. Yes, sir.
Yeah. If you don't find it, I can send the link also of that video. It's an YouTube video.
Definitely, sir. You can share that link,
okay,
sir,
fine.
so that I will repost it on the YouTube chat for reference, sir.
Okay, fine.
Yes, yes.
Let me see if I have it here right now. So
sure, sir. Dr. Sagar has replied, he is satisfied with the answer, sir, and he's thanking you, sir.
Okay, thank you. Yeah. Now, let me see whether I have this link of that video. I will send it right now. Okay, currently I couldn't find that link. I will search for that and I'll send it. But I have shown it to the participants during the lectures. You go to the investment.
11:30 बजे की ट्रेन आ जाएगी से 10-11 बजेगा, लेकिन वो आ जाएंगे। ठीक है।
See, you go to the slide number 79 in the casting, and there is a link called the investment casting on the right side. So there you will have the video. Okay.
Thank you, sir, for providing the reference. There are no posts on YouTube, sir.
Yeah, I think the participants also started leaving, so we
Yes, sir.
can probably now close the session.
Sure, sir. Sure, sir. We can close the section. So, thank you very much, sir, for this interactive
Okay,
live session.
I also thank the participants for coming over here. And once again, I'm telling that if you have any other question, you can put it in the forum and I will immediately send the answers to you. Okay. All the best to all the participants for your forthcoming exam. And don't worry about that. As I said, that it will be one of the simplest exams you have appeared for. Okay. All the best.
Thank you very much, sir. We will stop the streaming and we will close,
Sure,
sir.
sure.
Yes, sir. Thank you all.
Thank
Yes,
you,
sir.
Mr. Murali. Thank you.
Thank you, sir. Thank you, sir.